This question comes from Daniel, who asks, if the sun just vanished this second, completely gone as if it never existed, what would happen? And how long would we actually have? Great question, Daniel. Spoiler, longer than you think. And shorter than you'd hope. The first 8 minutes. Here's the thing. The sun is already gone. You just don't know it yet. Light travels at 299,792 kilometers per second. The sun sits about 150 million kilometers away from Earth. That means the light currently hitting your face right now, the light making you squint when you look out the window, left the sun approximately 8 minutes and 20 seconds ago. If the sun vanished at this exact moment, you would have no idea for another 8 minutes and 20 seconds. You'd be sitting there, perfectly comfortable, reading articles, drinking coffee, completely unaware that the thing keeping you alive had just ceased to exist. And here's the part that really gets people. Gravity also travels at the speed of light. Einstein showed us this, which means for those same 8 minutes and 20 seconds, Earth would continue orbiting a point in space where the sun used to be, like a ball on a string, still spinning after you let go, not yet knowing the string is gone. The sky outside would still be blue. The shadows would still be sharp. Birds would still be singing. Everything would look completely, perfectly normal. And then the 8 minutes would end. The moment it hits. At 8 minutes and 20 seconds, two things happen simultaneously. The light stops. Day becomes night. Instantly, completely without warning. Not a sunset. Not a gradual dimming. One moment it's noon. The next moment it is the darkest night you have ever experienced. People driving on highways would suddenly be blind. Aircraft pilots would lose their visual horizon in an instant. Anyone outside in midday would experience a shock so sudden and complete that it would take several seconds just to process what happened. At that same moment, Earth's gravity tethered to the sun snaps. The planet stops curving in its orbit and instead shoots off in a straight line, a tangent, into the darkness of space. The direction depends on exactly where Earth was in its orbit at that moment, but the speed is constant, about 30 kilometers per second. Earth becomes a rogue planet, drifting silently through the void. The moon comes with us. It's still orbiting Earth after all, and Earth's gravity isn't going anywhere. Our little companion stays. That's something. The first few hours. The darkness is total, but the cold hasn't arrived yet. This surprises most people. Earth's surface has been absorbing solar energy for billions of years. The ground, the oceans, the lower atmosphere, all of it acts as a massive thermal battery. The ocean alone holds an almost incomprehensible amount of heat. You can't drain that overnight. In the first hours after the sun vanishes, the temperature outside would feel roughly like a cloudy day, maybe a cold evening. People in warm climates wouldn't even reach for a jacket for the first few hours. The infrastructure of civilization, heating systems, electricity, food supplies, would all still be functional. For now. The psychological impact, however, would be immediate and catastrophic. Global communications would go into complete overload. Every government on Earth would be declaring a state of emergency simultaneously. Religious institutions would be overwhelmed. Financial markets, if they somehow stayed online, would simply stop functioning. There is no economic model for the sun being gone. The first week. Now the cold begins in earnest. Within 72 hours, average surface temperatures begin dropping noticeably, by around 10 degrees Celsius in most regions. This is still survivable. People in cold climates are barely inconvenienced, but the trajectory is relentless. Unlike nuclear winter, where soot blocks sunlight but the sun is still there is no recovery here. The sun is not coming back, the temperature will drop, and it will keep dropping, and it will never stop. By day 7, the surface temperature across most of the planet has dropped by 20 to 30 degrees Celsius. Tropical regions that once sat at 30 degrees Celsius are now at near freezing. Temperate regions are well below zero. Snow begins falling in places that have never seen it. The first mass migrations begin. People move toward the equator instinctively, Even though the equator is no warmer now, the sun is gone. They move toward underground shelters, toward volcanic regions where geothermal heat still seeps from the Earth's interior. Iceland, oddly, becomes strategically important. Plants begin dying almost immediately. Without photosynthesis, the base of nearly every food chain on Earth collapses. Grain stockpiles, which, as we've noted before, represent roughly 90 days of global reserves, suddenly become the most valuable substance on Earth. The first year. At 2 weeks, the surface temperature has fallen to approximately minus 50 degrees Celsius across most land areas. At 1 month, it's minus 70 to minus 80 in many regions. At these temperatures, exposed skin freezes in under a minute. Car engines refuse to start. Fuel lines crack. The infrastructure of modern civilization, not built for these conditions, begins failing systematically. Pipes burst. Bridges contract and fracture. Coastal cities, no longer protected by the moderating influence of solar-warmed oceans, begin to freeze. The oceans themselves take much longer. The sheer thermal mass of the world's oceans means they cool slowly. The surface begins freezing within a year, starting at the poles and spreading toward the equator. But deep ocean temperatures remain above freezing for far longer, centuries potentially. The oceans are Earth's last heat bank. This is actually important for survival. Submarine thermal vents, geothermal features on the ocean floor, continue pumping heat regardless of what happens to the sun. Deep-sea ecosystems around these vents would survive essentially indefinitely. Life in some form would continue. For humans, survival by year 1 depends entirely on geothermal energy. Iceland, Yellowstone, New Zealand, parts of Japan, regions sitting over geologically active zones, become the last habitable places on the surface. Underground bunkers with geothermal power could theoretically sustain small populations for generations. The far future. Here's the part that puts everything in perspective. Earth will keep drifting. In about 43,000 years, our trajectory would bring us close enough to the star Proxima Centauri, our nearest stellar neighbor, to potentially be captured by its gravity. Proxima is a red dwarf, faint and dim, but it produces heat. The surface temperature it could provide would be somewhere around minus 40 degrees Celsius at Earth's new distance. Still brutally cold, but warmer than the void. And if humanity somehow survived underground, huddled around geothermal vents, sustained by nuclear power, which requires no sunlight whatsoever, and managed to endure for 43,000 years, they might look up from their deep shelters at a new, faint red star appearing in the sky, getting brighter very slowly over thousands of years. A new dawn, just a much, much colder one. The final answer. So how long do we actually have? First 8 minutes, nothing. Complete normalcy. You'd never know. First hour, darkness and panic, but still warm. First week, temperatures dropping fast, plants dying. First month, minus 50 to minus 70. Celsius across land first year. Oceans begin freezing, surface uninhabitable long term. Survival possible only underground with geothermal heat 43,000 years. Earth drifts within range of Proxima Centauri. The sun is not just a light source. It is the engine of nearly every system that keeps this planet alive. The weather, the food chain, the water cycle, the magnetic field stability, human psychology itself. Remove it, and you don't just turn off the lights. You turn off the world. 8 minutes. That's how much warning we'd get. Probably enough time to finish your coffee.